Okay, so hello year 8. So last lesson, what I asked you to do was try and go and find half dozen or so different types of rock and describe them. So um, there are, of course, loads of different types of rocks. And what we're going to look at today is how these rocks are formed. Okay, so the first thing you are going to do is in assignments, there is this link. I'd like you to click on that and watch that, please. It'll take you about 5 minutes. And then that introduces what we're going to look at today, which is the rock cycle. Okay, so pause the video and go into assignments and click on that, please. Okay, welcome back. So what I'm going to do is I'm going to talk you through how the various rocks are formed. And I suppose essentially all rocks start life as molten magma or lava erupting from a volcano. So what happens is there is an eruption and the lava which comes out cools, and what we find is these cold rocks often contain crystals. Now we call these igneous rocks because igneous is like the old Greek word for fire, and obviously because they come from volcanoes, that's how they got their name. So igneous rocks are, for all intents and purposes, just cooled lava. Okay, so these often contain crystals, but what we need to understand is how these rocks actually then change and morph into other kinds of rocks. So what I'm going to show you is a short animation of how rocks are broken down, what we call erosion. Okay, so watch this and pay attention, please. Okay, hopefully that made a bit of sense. So the first thing you need to do in your books is draw something like this, because what we're describing here is a freeze-fall weathering. So imagine, if you will, this is a lump of solid rock, say for example, cooled lava or igneous rock. Now what happens with this is occasionally these get cracks in them like this, and water can get into these cracks. Now, often these are quite high up. So think about what happens to water at night time. It gets cold and it will freeze. Now here is what happens. As water freezes, water expands as it freezes. And so the water kind of pushes against the rock. Then during the day it melts, but then at night it freezes again and melts and freezes, melts and freezes. And what happens is over very long periods, there's pressure push on the rock. The rocks are pushed apart, and that until you get cracks. And eventually, what would happen is this whole section would break off. So ultimately, what you end up with is this. So as you can see, whole sections of rock will break off, and we call that freeze-thaw weathering. Okay, so what I'd like to do is just pause the video and just draw that into your book with a very brief explanation. So remember, solid rock, ice will get into the cracks, sorry, water gets into the cracks, and as it freezes, the water expands and the pressure put on the rock relentlessly by this freezing and thawing, is pushing against the rock, ultimately breaks the rock off. So the rock starts to break up. That's freeze-thaw weathering. Okay, so pause the video and do that now, please. Okay, so another kind of weathering of solid rock is onion skin weathering. And essentially this often happens in places like deserts. So again, you've got solid rock, often igneous rock, and it'll be baked by the sun in the daytime, get very, very hot. So as you know from year 7, when things get hot, they expand, but then at the night, they cool down, so they contract. And again, this constant expansion and contraction weathers the outer layer of the rocks, and so they become brittle and eventually just flake off. Okay, so because it flakes off like an onion skin, like in layers, we call this onion skin weathering. So once again, can you just draw a diagram like this with a very brief explanation of what's happening? So the constant heating during the day causes the outer layer to expand, and then it cools at night, it contracts, and so that makes the rock brittle. Okay, and it's this brittleness means that as soon as you get a stiff wind, those flaky, brittle outer layers just get broken off. Okay, so you've got expansion, you've got contraction, and let's use those words. Looking for a couple of sentences to explain onion skin weathering. So once again, pause the video and do that now, please. Okay, welcome back. So what can happen to our rocks? Okay, these bits of broken rock. Well, we call these broken bits of rock sediment. Okay, so and from them we can form new rocks called sedimentary rock. Now, often what happens is these rocks are carried in several ways. I'm just going to quickly show you this. So firstly, those tiny flakes of rock or grains of rock, this is what can happen to them. So sometimes these tiny grains of rock will have seawater in between them. I'll just quickly run that back to show you. These tiny grains here, so these are all weathered bits of rock. There'll be minerals between the grains, which are dissolved in water. Okay, so seawater has dissolved minerals. Here are your little grains of rock. And what happens is, as the water evaporates, the minerals essentially stick these rocks together, or these little grains together, creating sedimentary rocks. Okay, now another thing that can happen is this. Sometimes those sediments are moved downriver. Whoops. These sediments are moved downriver. So these bits of broken rock, there they are, they're going, flowing downriver, and they build up in layers. So you've got the layers of sediment get maybe washed into a river and are carried downriver, and then will build up into layers like this. Okay. And we can see how this happens. Okay, so if we just play this one, small, tiny bits of sediment, so the very small bits of broken rock, those can travel quite far in the water because they're quite light. But you can see big, heavy bits of rock, they tend to sink to the bottom. But either way, they tend to form layers. So, how do sedimentary rocks form? Well, essentially, this sediment, those tiny bits of broken rock which have been weathered away, get squeezed or compacted, compaction, and then cemented together to make new rocks. And sedimentary rocks often have very similar features. You can see here, they've all got these stripes. There we go, these stripes. So sedimentary rocks, a characteristic of sedimentary rocks is they have these stripes. Now, over millions of years, what happens is these sedimentary rocks can be forced and pushed deep underground. Okay, so this can also happen to igneous rocks, I should say. So let's just say we've got a rock here. Now, this is actually an igneous rock. This is granite, and we know it's an igneous rock because see, you've got lots of mineral crystals here. Look at what happens if it gets pushed really deep underground where there's lots of heat and pressure. Not quite melted, but have a look. So, just play that. Keep an eye on this. So there are our crystal grains, heat and pressure. And so you can see our rock has become a metamorphic rock. It's changed from this kind of rock, being squashed and heated, into this kind of rock. They've got the same minerals, but you've got these lines, what we call striation. Okay, so what can often happen, the way we know about these rocks, is geology will push these rocks back to the surface once they've been heated and essentially put under pressure. And so these are called metamorphic rocks. And some examples of this that you will know about or will have heard of are limestone, sandstone, mudstone, metaquartzite, slate, which often we find on roofs, and marble. All of these are examples of metamorphic rocks. Okay, so what you've got now is an understanding of how you get igneous, sedimentary, and metamorphic rocks. So what I'd like you to quickly do is just pause the video and write, how do you get, igneous, sedimentary, sedimentary, and metamorphic. How do you get three kinds of rocks? So a brief description, a couple of sentences, and then an example of each. Okay, so how do you get them? And then actually you could do it as a table. Example. Okay, so quite simple. There we go. And then you've got plenty of room to describe how you get. So yeah, a really simple table, please, describing how you get an igneous rock and an example of igneous rocks, how you get sedimentary rocks, and how you get metamorphic rocks. Okay, so pause the video and do that now, please. Okay, welcome back. So this is how we get the all these rocks and how they're all linked. So what this is, it's called the rock cycle. Okay, so I'm just going to explain to you how you get this, and I'm going to explain to you what you need. Okay, so firstly, as we said, we get igneous rocks, which are fire rocks. So basically, they come from volcanoes. So firstly, we get an eruption. So crystallization of magma to form igneous rocks. Okay, and if we have a look here, here comes our lava out of our volcano. We'll just click on that. Ooh. It's not going to let me do this. Bear with me. Okay, so I'm trying to talk you through this. So there's our lava coming out of our volcano, and that will cool to form crystals of solid rock, things like granite. Okay, and then over millions and millions of years, there is erosion and weathering, like we described. So erosion of solid rock, which produces sediment, small broken bits of rock, and those will often get carried away by rivers, streams, or by the wind if they're small enough. And then there we can see our sediments being transported in the river. They'll be carried down to a place where ultimately those sediments will build up. So deposition, or where they get deposited, so deposition of sediments. And you can see here, they build up into these layers. Okay, so that'll be, and then gets compacted, that sedimentary rock. Ultimately, it gets squeezed and squeezed and squeezed into sedimentary rock, like I said. And then, as you get movement of the earth, some of the rock here gets pushed underground, where it gets heated and put under pressure. So it morphs, it changes into a different kind of rock. And then ultimately, if it gets pushed far enough underground, it will melt back into igneous rock or magma and possibly erupt from another volcano. So as you can see, it's a big cycle. That's why this is called the rock cycle. Okay, so here comes your part. Right, so what I would like you to do in a moment is log into Kerboodle. Okay, now hopefully most of you know how to do this, but I'm just going to show you just in case you're not familiar. So if you log into Kerboodle, you'll come up with, click on Key Stage 3 and you'll see this. Okay, so this is what you're looking for. You go to Digital Book and you want this one, Activate 1. And if you click on that, you want page 144. So what you would do is just go to page at the bottom. I'm already on it, but just type in 144. It would come to this page, and it tells you about Rock Cycle. So first and foremost, what I would like you to do is I want you to copy this diagram into your book. Okay, now it looks complicated, but actually it's nothing that you haven't just gone through. Okay, so you need to copy that into your book. You've got all the explanation of how it happens, and then what I would like you to do is have a go at the summary questions here at the side of the page. Okay, now to answer those, you'll probably need a quick read through of these as well, but you do have all the information you need. Okay. So a couple of little things about how to log into Kerboodle. If I just quickly log out and show you how you log in. So what you need is your school email address. Now mine's p.stevenson@thamesmead. And then you'd use the first part of your email address. So for me, that would be p.stevenson, but for you, it's whatever your code is for the first part of your password. Okay, sorry, the first part of your email is your password, and then the Thamesmead institution code is JJ9. So you can see you put that in there and then click login. Easy as pie. You log in to Key Stage 3 Science. It's the first one here. There it is. Digital book, book number 1, page 144. Okay, you can see it there at the bottom. All right. I'll be online, so if you have any problems logging in, I will help you, but hopefully that is as clear. If you need to check the instructions again, please do so. Otherwise, good luck.